Welcome to The Rocketry Show at TheRocketryShow.com. A few weeks ago, The Rocketry Show lost a dear friend, and a dear friend to many in the rocketry community. Jeff Kodysz passed away from a number of health conditions that cropped up on him over a very short period of time. He was not able to recover from that, and that makes us very sad. He was a contributor to the show in many ways over the years, the most significant of which is a contribution you see every day in your podcast player. Our latest logo, which is a really cool 3D rendered rocket that we use for our logo everywhere, was designed by Jeff, and he did a great job with that. He did a great job on a number of things. He's a very talented person, very talented rocketeer, 3D printing and etching, laser etching of items were things he did very well. And all of us in the show learned a lot from him, and he'll be missed. Jeff was on the show about 3 years ago, and we talked about 3D printing. So in the memory of Jeff Kodysz, here is his interview with us on The Rocketry Show at TheRocketryShow.com. Jeff, wherever you are, rest easy, my friend. The suffering is over. Welcome back to The Rocketry Show at TheRocketryShow.com. We've got a fun topic here to talk about, and it involves 3D printing for rocketry. And to talk about that, we have our guest, who's the president of our club, Jeff Kodysz. And welcome to the show, Jeff.
Hey, how's it going, everybody? Thanks for having me on. It's good to be here.
Nice having you.
Good to have you. Yeah.
So, 3D printing for rocketry. Now, you've got a nice little setup for hobbyists in your basement there, right, Jeff?
Yeah, I've got a couple of different 3D printers. There's two different technologies that I've got. One of them is it's called an FDM, or fused deposition modeling. It uses extruded plastic, which is kind of like a glue gun on a CNC machine.
Okay.
And then I've got also a DLP printer, which is uses a resin that's photosensitive, and it uses an LCD screen underneath to fuse layers of resin. The resin's photosensitive, so when the light hits it, it solidifies. And
so that's kind of known as an immersion printer too. Is that correct?
Yeah. So you've got on a 3D printer, you've got a build plate, and that's basically where the model is stuck to when it starts, and that's you build from the build plate. Now, the immersion printers, the build plate is submerged underneath the surface of the resin to the bottom, which is a clear film, and then
cool.
Different technologies use a different method of solidifying the resin. This particular one uses an LCD panel, and it puts a picture of whatever layer it's going to print, and it solidifies, and then the build plate moves up by the thickness of the layer, whatever you set it at, and it just builds layer on layer on layer until you've got a 3D part.
Now, most 3D printers that people are familiar with, they always hear the term MakerBot. And as I understand it, MakerBot is just basically the first version of printer that you mentioned. It's kind of an extruder that is on a CNC machine. So what is the material typically that you pipe through those?
So the most common thing, if you think about if people don't know, you picture weed whacker line, string trimmer line. It's what it kind of looks like when it's on the spool, but it's made of different types of plastic for different purposes. The most common, and the one that was the start of it all, is it's called PLA, or polylactic acid. It's basically a plant-based plastic, and whatever its properties lend it to easily extrude, and there's a lot of science involved with the plastic state of the plastic itself, and when it's flexible and when it's not. But they started with PLA. That's the most common. When you buy a new printer, it usually comes with a test roll of PLA, or at least a partial roll. But they've got so many different kinds of filaments now. You've got nylon. There's ABS. There's PETG, which is polyethylene tetraphthalate, I think. They all have different properties. Some of them are more flexible. Some of them are UV resistant. Some of them are more heat resistant. Depending on what you want to do with the end part, you've got other options. They're mixing in wood fiber, wood dust.
Yeah,
with
I've heard
some
that.
of them.
Yeah.
Yeah.
Mm-hmm.
So you can print something out and stain it just like you would a piece of wood. Some of them they're now working on conductive extrudable plastics, so you can basically print a circuit. You set up the schematic, and you get the circuit trace, and rather than having to etch it into a board, you just print it with the filament, and you've got yourself a circuit.
That's really cool.
So that might make some night flight rocket possibilities very interesting.
Yeah, that's what I'm thinking. LEDs embedded into your airframe. Blah, blah, blah.
It's only imagination,
So these different types of plastic, I imagine, would make for useful purposes for different rocket applications. So I'd imagine which one, just to say, one of the discussions I saw, backing up a little bit, was one where people were using 3D printers to make fin cans. And so they were cautioning folks that most of these printers lay down their layers of plastic in a way that essentially gives you grains in the plastic. And if you do it the wrong way, your fins could break off. So if you want to go into a quick discussion on that and which type of printer would be the best to use for fin cans and things like that.
Well, the nature of extruded plastic, the PLA, the nylon, that kind of stuff, the FDM, I don't know that it's any different than a balsa fin that has grain in it. You just have to orient it the way that you think it's the strongest. The filament itself is a lot stronger than a balsa grain, though, so it's not such a big deal. I think weight is more of an issue than the strength. Yes. And okay. I know, Jim, you've built I saw you fly your V2 that was entirely 3D printed, and it was really cool.
Yep, absolutely.
But you with that technology, you do have banding. Every layer that is put down, there's a slight ridge. It's almost like, I don't know, man, I'm going to date myself now. Nobody's going to know what I'm talking about. It's like the grooves in a record.
No, it's exactly it.
If anybody that's listening even knows what a record is.
Hey, vinyl's back.
Yeah.
Is that like a wax cylinder?
Mary had a little lamb.
It's little magnetic fields on a wire.
Whoa. Yeah, but that's a great way to describe it, though, because, the whole purpose of me getting into 3D printing was something very basic and very simple. I wanted to make rail buttons or rail guides. It's just something that I could make. I could make it conform to the curve of the body tube, and I just wanted to do that. And for my TARC team, it gave me an excuse to go and look for 3D printers. And I found one that was it was incredibly cheap compared to other printers. It's a Creality Ender 3, which is it's a build it kit. You get all your parts and you just have to put it together. But it was like $185. I'm like, you know what? I'm just going to give this a try. And I talked to a bunch of people, and they said, if you want to get into 3D printing, that's the best printer to get for a noob like me. So I bought this thing and I started playing around with it, and I went and I got instead of designing the file myself, because I'm not working in CAD is a little bit problematic for me, and I'll just leave it at that. But I just went on to some websites, and I was able to download the files for what I wanted. There's tons of websites out there that have pre-made files. So I was like, okay, I see there's tons of stuff. Jack Hydrazine does quite a bit of files that he posts up. He's on Facebook too, and he's always around the NAR sites, so you see him around. But he posts a lot of pre-made 3D printed files, and I found a whole bunch of his rail guides, and I just downloaded them and I started printing them, and I was like, wow, this is really cool. So the next step I took in that was I found a file for a mosquito clone. It was a one shot. Most of the time, with rockets, I've noticed for the pre-made files, there are a couple of parts that you have to glue together with either CA or some kind of a plastic cement or something. So this was a one-piece, like, mosquito, which, you know, it looks like a mosquito. It's got the launch lug already built into it, so it's just a matter of letting it go and print. And I printed it out, and I was like, "This is really cool." We flew it a couple times with the kids before we started making our rail buttons for the TARC competition, and it turned into a thing. And you're right about the weight, though, because I think the mosquito came in at it was probably about 60 grams, maybe not 60, but it was a lot heavier than the real one. So that's a consideration that I noticed in making an entire rocket out of 3D stuff. But so what are some tips that you would say, Jeff, about depending upon what you want to do, what would you think would be a good first step for somebody who just wanted to get into it?
You know, I would say take the route that you did. The Ender 3 is an excellent starter printer. The results that you get out of it for the price point are unbeatable. My dad bought one and I helped him put it together, and the very first test print was just beautiful. I mean, there's a lot to learn. You know, it's not just you're going to take this thing out of the box and it's going to start printing everything you ever wanted. You know, there's techniques, there's settings depending on the plastic that you choose. You have to get the settings right. You know, the layer height, you have to level the bed right, and you learn all this stuff, but it's easier to learn it on something that you don't have a whole lot of money invested in. Right. You know, there are turnkey printers now that, you know, there's very little to know. You plug in the numbers and it does the whole thing for you. It levels itself. It, you know, heats up itself to the right temperature based on the whatever material you've entered into it. But, you know, those are multiple $1,000 machines. They give excellent results, right. But you can get those results with a little bit of practice and some hard work and some learning. And, you know, you can be putting out the same quality part and you don't have that whole cash outlay. So I think going the route that you went would be the way to go. I went, my first 3D printer was a Robo 3D R1. And it was old. I bought it brand new, but I bought it a long time ago. And I never quite really got it dialed in the way I should have. And I ended up moving. I actually got myself a Creality CR10. And it's doing real well for me. But even still, you know, just the ambient temperature in the room can have an effect on the print. You know, I was printing... it was I don't know if anybody knows a Battle Mech. It's a board game.
Oh, yeah. I've heard of it.
I was printing a Battle Mech, and I was printing in parts because it was big. And I printed one part, and it came out perfectly. And the next day, I printed another copy of the same part, and I tried 8 times, and I couldn't get it to stick. Well, here, the temperature in my basement dropped by like 4 degrees, and that was enough to where the part wouldn't stick to the build platform anymore.
Wow.
So they can be tricky, but there's a lot of information available online. There's a lot of places that will help you out. A lot of groups you can join, and, you know, they're filled with good guys. Plus, you know, anybody that wants to get into doing this for rocketry specifically, the sky's the limit with what you can build. Doing the FDM printers is only one technology. You're left with a great part, but you do have some filling to do when it's done. You know, you're gonna right. Put a couple of coats of filler primer on it, and you're gonna do some sanding to get it nice and smooth. It's not much different than a balsa wood part, other than, you know, obviously the weight. But, you know, still, even with the weight being an issue, there's other methods that can be used to mitigate that. You can you know, lower the infill, for instance, which is how much material it puts inside the part. And that can drastically reduce the weight and reduce the time it takes to actually print the part, which is another issue. You don't press a button and out pops a part in 5 minutes. Some of these parts take hours and hours and hours to print. So, you know, I don't know how long it took me to build to make that V2, but I'd imagine it was probably over 12 hours.
It was 14 hours, and I ended up, it actually split it into 5 different sections. So I had to print a section at a time. So total time was about 14 hours. So, and that's a nerve-wracking time, I've noticed, because I was worried as it was building the part. I'm sitting there watching, I'm like staring at it intently for an hour, and then I don't see much happening. So walk away, go back to it, and just stare at it as it's doing its thing. And what was interesting was I was a little nervous because, like, at one point, the extruder, as it was going through, it lays down these little lines, little itty-bitty lines of material as in that pattern. And you're worried that if, like, a little bit comes out or too much comes out or not enough comes out, it's going to mess up the whole part. And so, I mean, it went okay. I was really surprised because I've worked with other printers in the past just to test the waters a little bit, and I hated them because I could never get it right, and it got frustrated. So I didn't even look at it for a while. And then when I started getting back into it, I was like, okay, there's got to be something better. And so I still have that. It takes a long time to build a part, and I'm nervous that it's going to screw up. And I was pleasantly surprised that this particular machine seemed to be a good one, I guess, and it didn't. And then taking all the sections and then figuring out how to glue them all together the right way so that they're not going to fall apart was another thing. And since this rocket was an entire 3D printed rocket, I also was concerned about heat, because I had a motor in there, and I wanted, because of the weight, it came in at like 300 grams. I had to use a composite motor, which is generally a little bit hotter, and I was worried that it would make the material soft because around the motor mount. So I took a trick from Joe Barnard with his 3D printed gimbal, thrust gimbal that is 3D printed, and I put a liner inside the motor mount, like a cardboard liner, just right in there. And the motor sits through that, and it actually works as an insulator so that it didn't melt the plastic, which I was concerned about. But thanks, Joe. You got a little. I took one of your tips, and I'm actually using it in other applications. So
speaking of on that same subject, there, I've noticed in the latest NAR letter, John Hockheimer talked about being careful of where you 3D print components for your rockets for that same reason. So.
And that's where
it's interesting stuff.
That's where it's important to choose the right kind of material too. PLA is usually pretty good. Like you said, Jamie, you put that liner in there and it's pretty much okay. But you wouldn't want to put a staged motor in something like that, because you'd end up with a one flight rocket. Which might be okay, but you like to keep them around a little while. But some of the other materials are being built specifically with more heat resistant characteristics. The problem with that is when you're using this particular type of technology, you need to be able to extrude it, so it has to melt at a certain point. So you can't make it too heat resistant, or you'd never be able to print with it.
Right.
Which is where some of the other technologies are coming into play. The resins, some of the resins are more heat resistant, and you can print a heat resistant part with a resin because it doesn't use heat to make it. So,
got it.
I had and lost when I finally flew it, a 3D printed Cinerock clone. Nice. And cool. I didn't print this one, so I don't know actually what it was made of. But I first got it out when we went to NIPower, and I didn't fly it. But when I took it back to the hotel room that evening, and it wasn't that hot at NIPower, was it, CG? I don't really recall.
No, not really. No, it was just
but
a lot of grass. There was
just a lot of grass. There was some sun, and when I took it back, I noticed that the Cinerock had deformed because whatever it had been sitting on, it got warm enough it was black plastic. It got warm enough in the sun that it actually melted a little bit, and so it was slightly flattened on one side to the shape of, I think, my bag that it had been sitting on or something. Which is fine. I mean, you had to look at it closely to see it, but it was definitely, I was like, it bugged me.
Yeah, so because then I flew it there.
Yeah, because it's there. So then I flew it and I lost it.
So it's a moot point then anyway, right?
Right.
Exactly. Doesn't matter. It's out there somewhere in the grass in northern Massachusetts. So.
Yeah. I want to take a moment to ask for someone who's getting into 3D printing for the first time. What do you recommend for reading materials or whatever to help someone get up to speed quickly?
Wow, I'll tell you what. I learn so much from YouTube videos. There's several YouTube content creators that specialize in 3D printing that I follow. Do a search. Just go into YouTube, do a search for 3D printing, and just ride the wave of tutorials that will pop up on your screen. I don't know. I learn a lot better by seeing things done than by reading about them. I tend to get lost when I read stuff. But these are in small enough chunks that you watch somebody and write down settings if they suggest them, and try them out on your own machine and see if that works for you. If it doesn't, tweak it a little bit. There's online communities that you can go to, but I personally learn most of my stuff on YouTube. I'm looking through my list right now to see if I can find somebody that I can recommend, but for whatever reason, it's not happening.
In your experience, though, you could even find tutorials for your particular printer as well, because sometimes they're a little different.
Yeah, you can be as broad or as specific as you want in your search. And, the one thing that you got to keep an eye on is there's very often different versions of a printer, especially, like the Creality printers. They make updates periodically and don't always publish those updates. So you could have something that's 3 months old that has a specific issue or a bug that they've fixed and you don't really know about it. So try to get the most current videos that you can find on your specific printer. But yeah, you could do, 3D printing in general or specific to your printer.
Well, I could tell you one channel that I'm actually subscribed to. I didn't subscribe because of the 3D printing, but it seems to be his specialty. There's a YouTuber called Neris, Nerys. The reason I'm subscribed to him is because he covered your speech CG at NARCon 2016. He's a Rocketeer, but he also has a channel which he calls Today's 3D Print. So he covered just a little shout out there to Neris. I don't know anything about if he does tutorials on 3D printing. I don't know anything about that. I just know that because of the rocketry stuff that he does, that's why I subscribe to him, and he's always doing 3D printed stuff. So yeah, and he has a lot of videos of at least one or two Narcons past, like 2016 and Narum as well. So that's one user that I know does a lot of 3D printing.
Yeah, another one I found here is the 3D printing nerd. He's got a pretty good channel. Joel, I believe, is his name. And from there, you'll see other ones pop up. It'll know that you've looked at it, and it'll suggest things that are similar. And that's how you kind of find your way through all these. Look at the recommendations after your initial search, and you'll find even more.
What are some tips and tricks can you guys think of for people for the most success when people are doing things for rocketry here? I know you mentioned different resins or different types of plastic. What kind of rules of thumbs can you give for folks with getting into this?
When you're just like Jeem suggested, go online and look for something that somebody's already made. Take out that whole design portion of the procedure out of the picture. Look at what's there and look at the ratings. These sites that have these files for download have ratings, and so when you download it, you can print it, and if it works for you, you can leave a rating as to the quality of it or how easy it was or whatever, and go with higher ratings if you can. and print some of those and see how they work for you. And from there, you'll learn what works and what doesn't.
With a minimum of effort.
Yeah, it's not like you waste a whole bunch of time designing something in CAD and then finding out it didn't work right. So if you look at the end product, you'll know what's going to work when later on you get into CAD. I actually started doing CAD because I wanted to make stuff for 3D printing. That's what actually got me into doing CAD. So I kind of did it a little bit differently, but there's the biggest site I think to send people to for 3D objects is Thingiverse.
That's it. Yep.
And there's another one, My Mini Factory is a good site too. There's also a search engine for 3D models. It's called Yeggi, Yeggi. And that looks at all of the other ones, and you put in a search term and it tries to find throughout all of the, model repositories.
That's cool, because I didn't know about that one.
Yeah. Yeggi's a good site. It kind of condenses it all down and saves you a little bit of hassle,
That's cool. One of the things that I've noticed that I would say is a big thing is learn how to level your printer before you print. And this is just, I don't know anything about the immersion printers, but this is just for the ones with the extruders. If you don't level your bed, what'll happen is the plastic will ooze off of the design and it'll just be a big mess. Or the print head will touch the bed, which you really don't want when you start a print. That'll cause drag and it'll cause the plastic to get all messed up, and you'll end up with this big ball of melted stuff that is not a rocket part. So learn how to level that. And the Creality one, actually, people say that it's hard to level. I didn't find that at all. I eyeball it. Usually what you'd want to do is you want to get a piece of paper between the extruder and the head before you start a print. And if you can get a piece of paper through there, then that's about right. I've gotten to the point where I can actually eyeball that, and I always level before every print. Even after I just finish a part and I'm going to start another one, I will still level it between parts just to make sure. And that saved me a lot of hassle. I learned that the hard way when I first started doing it.
Sure, the process of breaking apart from the build plate when you're done with it can throw it off a level. So it's wise to re-level it every time.
I have a question. So you've mentioned, and I think probably most people who've seen 3D printed objects know that they often result those ridges. You get those ridges that result. Is there a way of, is that either sandable off, or can you fill it with something? Is there a way of dealing with that stuff if you like to make your rocket smooth?
Well, different materials will sand differently, even amongst like PLA from different manufacturers, or if they're filled with something or whatever, they'll sand differently, but you can sand them. But what most people for rocketry end up doing is they'll take a good automotive filler primer. You have to get it at the parts store, and throw a couple of coats of that on there and then start sanding it. And so basically you're not really sanding off the ridges, you're filling in the grooves.
Right.
The only thing you just got to make sure of is that, and if it's, like if you're printing a nose cone, for instance, you've got your shoulder, so you don't want to get any of that on the shoulder because it might throw off the diameter, and it might be too hard to get in and out of the body tube. I mean, you can always sand that, but it's easier to not have to do it.
Right.
To fix it, don't screw it up and you won't have to fix it. But yeah, that's the easiest way. There's other options too, but they all add weight, so they're not really applicable for rocketry, I don't think. There's some epoxies that you can get, and you basically paint this epoxy over the surface of the 3D printed part, and it will self-level and fill in the grooves so it's nice and smooth. But you lose detail when you do that, and it adds a ton of weight. So just for the weight reasons alone, I don't recommend it for model rockets. I would stick with sanding and the old school sanding and filling and sanding and filling and sanding and filling.
Yeah.
And you can use the same stuff that you use on balsa wood if you like. If you like the fill and finish, you can use that. It doesn't tend to stick to the PLA as well, though. So you kind of got to go.
Okay.
You got to go in thinner layers with, something like a wood filler like that. So, because you're sticking to plastic, you're not sticking to wood, so it doesn't have the same tooth that wood has to grab onto it.
The one thing I did notice too is watch your weight, because you can, if you're thinking about doing a 3D printed rocket, that's cool, but just remember you're going to need more motor, and make sure that you you get your center of gravity, your center of pressure is like worked out so that you're going to have a stable flight. The PLA V2 that I printed, I had to put in about 125 grams of nose weight in the top section of it. So it's heavy.
Those fins are dense.
So it's a heavy rocket. So you also have to be careful on your ejection charge too, because the nose cone and the weight is a lot, and you got to make sure that ejection charge is going to be able to push that nose cone out if you do a full rocket like that.
And another thing you can consider, if you don't like to do the sanding, is switch to a different technology of printer. The other printer that I have other than my FDM is a resin, which I think I mentioned earlier. The resin printers, technically you still do have lines, but they are so minuscule that you can't even, you might be able to see them looking at the bare part, but you can't feel them. And once you put a coat of paint on them, they're absolutely gone.
Is there any difference in the build time between the two technologies?
It's totally dependent on the part. So some things will print faster in one or the other, but not everything. It's not, if it prints faster on one printer, it doesn't necessarily mean it's the same on the other printer. I don't. It's kind of hard to explain. You're still doing the same process. You're building up layer by layer. So basically, your printer will draw a layer with the FDM printer. So whatever the total length of all of the line that it's drawing takes, you're doing that all at once on a resin printer on a DLP. So, but you do have an exposure time. So it has to stay. It has to be. Right. It has to be illuminating that particular layer for X amount of seconds. So it's really hard to say without a specific model, in mind. It does take a long time. Also with the DLP resin printers, there's also another technology of resin printers that uses a laser. It's an SLA, stereolithograph. Those are usually quicker. Instead of having instead of having a illuminating panel underneath the filament or the resin vat, you have a laser that draws on the resin vat, and it's usually quicker. But again, different printers from different manufacturers will print at different speeds. Different resins and different filaments take different amounts of times, so it's kind of
different.
Depends.
Too many variables, huh?
Yeah, it's like the old saying, it depends.
Do resin printed objects have the same issues with heat as filament printed objects?
Well, just like different filaments, you've got different types of resins, and those resins will have different properties. So some of them are more resistant to heat than others. I have not used my resin printer to print motor components. Some guys have been using them to print like retaining rings. You've seen the Estes engine retaining rings that screw on.
Yeah.
Some guys will use those. So they'll take a little bit of heat. I would like to do some tests. I haven't gotten around to doing any tests on to see exactly what they do. I use mine mostly for, like detail parts on a scale model. Or nose cones or something like that.
Right. Components.
I've made some small nose cones for some Micromax rockets that I've been working on. And it's beautiful for that because those are, little tiny nose cones are a lot more of a pain to sand than bigger ones.
They are.
Yeah.
Especially when you have giant hams for hands. They're hard to hold on to. So, The resin printers, I like the resin printers. The resin, compared to the FDM, the resin is smelly. And it's a little bit more expensive than a spool of filament. A little quart of resin costs sometimes upwards of $30.
Yeah.
Okay.
So you do get a lot out of it. And what you get out of it makes it worth the price, in my opinion. But, that's something else that you have to keep in mind is the cost of the raw materials going into it.
Sure.
Just the capabilities that 3D printing has given us these days. I mean, when I was a kid, I don't know if anybody even knows what a cork is still. I used to take paper towel tubes and stick a cork in the end of it. And there was my nose cone, and then put some cardboard fins on it, and boom, I've got a rocket.
Yeah.
And nowadays, kids just push a button and a nose cone spits out.
Now, do you think somebody who's first getting into it, do you think those public maker spaces are a good place to go if you're totally lost and go, I want to do this, but I don't know anything about it?
That's an excellent place. Yeah, it's an excellent place to get your feet wet, and it's an excellent place to learn. The guys that are at the makerspace can help answer any questions you might have. Even if you've got your own printer and you're having some trouble with some stuff, you might go to a makerspace and say, hey, take your file with you and go, can somebody help me print this? I'm trying to print it on my own printer. I'm having some trouble.
Oh, okay.
It's a great opportunity to learn.
Yeah, and they'll teach you right, especially if you've got some really dedicated folks. My local one here is the Akron Makerspace, and Devin and the gang there, they're great. So definitely take advantage of a makerspace. And it's a good way to get exposure to laser printers before you plunk down any money.
And that's right.
Yeah, you can figure out what technology you like the best and go from there. I know that there's some of the manufacturers are making parts from 3D printers now that, normally they wouldn't offer a kit, but they can make a neat 3D printed nose cone. And it's not as good an economics of scale thing as, turning them on a machine out of balsa wood, but what you can do with it is just a lot better.
Well, I was, as we were actually talking before the show, and I've got a Semrock MX Mars lander, one of my favorite designs, and it's this little tiny thing, but half of that is a 3D printed nose cone. The nose cone is half of the rocket, where, like, if you're familiar with the Mars lander, you know how it goes into 3 different sizes, essentially. But the whole part, like, aside from that lower where the fins come out or the landing gear come out, that whole top part is 3D printed. And I was amazed at it because I was looking at it going, well, there's no ridges on this. What is, like, how did this happen? And it's really light. So.
That particular part is actually made with an even different type of 3D printing. It's called an SLS. It's selective laser sintering. So basically what that does is there's a powdered plastic that gets laid down in a very thin layer, and then a laser draws the layer on top of that powdered plastic and fuses where it hits. And then another layer is put over the top of it, and then it continues on and it builds it up that way. Those were
the
some
detail
of the,
on it is really nice.
Oh yeah, that's the beautiful thing about those is the detail is just, you can get such fine detail with them. And those were some of the very first 3D printers. That particular type of 3D printing was some of the first that they used commercially for doing, rapid prototyping and stuff like that. And they still do use them. Those particular parts I know are made on an industrial machine that does, bigger parts. And the guy that Randy uses to make those parts does those on the side for him. So those are top quality parts.
I could tell when I just got it out. I'm like, another Mars lander? Yes, please. Yeah. So it was so small. It's cool.
Those are fun. Now there's another company, Boyce Aerospace, that's making scale kits, and they're doing a lot of 3D. Almost all of their kits are all 3D printed, and I've seen pictures on their website, and they've got a whole, I don't know what you'd call it, a farm of 3D printers working constantly, kicking out parts. That's the new thing now. It's, I almost hate to see it. I like it. I hate to see it because, I'm old school. I like to build stuff. And it almost seems like cheating when you can just get the file, put it in the machine, and wait a couple hours, and it's done. I'm torn sometimes between how easy it is, and then I think back and I go, you know what? I've sanded enough things in my life. I can do things easier now. I owe it to myself. So
we all love to sand, don't we?
Hey. So
very cool.
I enjoy the process of building, and I usually don't buy kits that are easy to assemble or pre-assembled. I'm not really interested in that, and I'm not really interested in buying a builder's kit that somebody else has already put together. But I wouldn't mind, lightening the load of certain aspects of building, and shaping fins or what have you. Or if I wanted a nose, there's a particular Estes makes a certain type of nose cone that they used to sell, the BT60 nose cones that they used to sell in 4-packs, and they sell different ones now, and you can't get those ones. And I really like that nose cone. So I would love to be able to just print, my own at will. I have a few of them. And I'm holding on to them because, but yeah, I don't think I know what you mean by saying that it sort of feels like cheating, but there's other stuff we can sand.
Well, I didn't say I wasn't.
We still have to paint it. So
there you go.
Some kind of cheating I'm okay with, but
yeah, I mean,
the 10-year-old me is going, come on, man, you can make this out of balsa, and the 47-year-old me is going, yeah, but why?
That's it. I have this grand idea of I've always loved the Soviet N1 moon rocket design.
Oh,
just
yeah.
because, and I always thought it would be so. There was one kit that was put out, but it was ridiculously complicated. I'm like, I'm never going to do that. All kinds of paper wraps and all kinds of crazy balsa wood stuff. And I was like, I could probably make a 4-inch N1 and then maybe 3D print the parts for it. So that's been in the back of my head. Well, if it ever happens, it will. But that would be a cool project for something like this, I think.
And the N1 is one of the few rockets you could actually make a scale model of and have it look just like it, because being a big cone, it's naturally stable.
Yep.
Yeah, that's true.
Well, somebody on one of the groups on Facebook just built a 3D printed Vostok. And it was
nice.
Wow.
It was amazingly beautiful. The detail was just unbelievable. So, and that's the Soyuz is one of my favorite rockets.
Yeah.
And I would love a good kit. I would settle for a good model that I could 3D print. A good 3D model that I could make on my own. But
now, if it flew, did the boosters come off and all that cool stuff?
I was going to say, up the ante.
I don't know if they came off, but they were separate. So they were printed separately and then attached. I don't know if they actually came off in flight, but
nice.
It was
cool.
something that even if those didn't, we could make it happen.
Yeah,
exactly.
So,
all right. Well, thanks a lot for coming on and talking about the 3D printed stuff. I'm sure we may have you back on for a little segment if there are more questions on that from listeners as they hear this show.
Happy to come back anytime you like. There's always going to be questions because this is just such a rabbit hole to get started down.
Yes, a wonderful rabbit hole.
We haven't even talked about CAD, and that's part of the fun too.
Oh man.
Yeah.
Oh, well, I guess we'll have to have another installment, 3D printing part 2 at some point. So.
Maybe not for Gene, but it is for...
Well, I never said I wouldn't do it.
we can get you pointed in the right direction for that. So,
all right.
Yeah, it's my pleasure to be here, guys. Thanks for having me.
Thanks for being on.
Yeah, thanks a lot.